Okay, we're going to start with assignment 3. This is question number 4. And it's about the largest mass that you can push. So it tells you that your force applied is 300 newtons. And it tells you that the coefficient of friction is 0.5. And they want you to push something across the floor with this force. And they want to know how big of a mass can you push with this force. So let's draw the free body diagram. Okay, so we have the applied force, F applied, which we would be pushing with. And of course, we're going to have to fight against the friction force right here working against us. We also have to consider that we have some vertical forces. We have the normal force, Fn, and the gravity force down below. So, to figure this out, we have to start with our F net x and F net y. So let's do F net y first. Now what you'll do here, rather than give you the actual solution, I'm just going to give you some hints, okay? So you're going to put your Fn and your Fg, okay? And of course, because we're talking about the up and down, when you push on this, it's not expected to move in an up and down direction. So when you get to here, you have ma, and a becomes a 0. And so what this eventually will let you do is figure out a value for the Fn. So that's the normal thing that we would do. We're going to solve for Fn. Then when we get to F net x, okay, the thing here is friction and applied force. That's force applied. Because we're pushing this, and when you push things, we tend to push at a constant speed. The question doesn't mention accelerations of any kind, right? So that means that we're pushing at a constant speed. So we can make the decision that when we do the ma here, this a will also be a 0. And this is our mu Fn, right? Don't forget the negative for the opposite direction, and F applied. Right? Now, the question is, or the trouble people were having is where the mass went. Well, don't forget, if we don't have the mass here, the force of gravity we don't really have a number for. All we can do is use mg. So when you put your force of gravity in here, you're going to put in mg. And that's going to mean that when you do the Fn, you're going to have an m in there. Let me do that part for you, just to kind of show you what I mean. It's easier to... Let me finish this part of the equation, right, to show you where the m comes from. So we said this would be a 0, this would be Fn. Now here we have a problem, see? We have negative mg, negative for down, so we have 0 equals Fn, but the best I can do here is to write 9.8 for the g, but I have to leave the m because I don't know what my mass is going to be. So what that means is that when I do the next step, the normal force, when you move it to the other side, you get 9.8 m. So you see your normal force, which now is going to end up down here, has an m in it. So when you get to this stage, you're going to have this, you're going to have your mu, the mu was 0.5, right? But you're going to have the 9.8 m here as your normal force, and then your F applied, which you know is way up here, 300 newtons. So you see, you should be able to solve for that m, and that'll be the mass that you can push. So that's the trick. In right here, the normal force has an m in it because of gravity, because we didn't know the value of the m from the start. So